Hi, in this video I'm going to be doing an example of how to find an empirical formula for a hydrate. I'm going to do example number 2 on this worksheet entitled Empirical Formulas of a Hydrate. So I have 1.21 grams of this hydrate. I'm not sure how many waters are attached to this anhydrate substance. But then they give me 1.03 grams of the anhydrate, the after heating. So what I usually do first is I take the difference between the hydrate and the anhydrate. And in order to do that, you're going to need a calculator, usually. Good thing I have my calculator with me. Alright, so plugging this in, see it, alright, there you can see it. We got 1.21 minus 1.03, that gives me 0.18 grams. So what's happening is the difference between the hydrate before heating minus the anhydrate after heating is the mass of the water. Once you have that, you're going to convert your water to moles by multiplying it by 1 mole, dividing by the molar mass of H2O, which is 18 grams. You add up the atomic masses, remember, and that is going to equal 0.18 divided by 18, 0.01 moles of H2O. And then what I'm going to do is I'm going to take my anhydrate, 1.03, because really the hydrate mass, the only time you really need that is when you're trying to find the water mass, because ultimately you're comparing the anhydrate to just the water, and you're trying to find the lowest whole number mole ratio of those two substances. So I got 1.03 grams of anhydrate, PbC2H3O2, and there's 2 of them. I'm going to multiply it by 1 mole, divided by molar mass. Alright, so this one's a little bit trickier. Molar mass, we're going to have to, first of all I got to find my mouse, there it is. We're going to have to use the periodic table. So looking at lead, Pb is right down here, that's 207.2, already rounded to the nearest 10. And I'm going to add my carbon, which is 12, but there's 2 of them. And then my hydrogen, which I memorized is 1, it's right over there. And there's 3 of them, apply that by 3. And then there's oxygen, which is 16, oxygen's right there. And there's 2 of those guys. And all of this stuff I'm going to multiply by 2. So the mass of 2 carbons, 3 hydrogens, 2 oxygens, all in these parentheses, so I multiply that mass by 2 in the end. Alright. Let's get away from there. Alright, so you can see my calculator. Alright, there. Alright, 12 times 2 is 24, plus 1 times 3, 3, plus 16, gives me 59, multiply that whole number by 2, gives me 118, but I got to remember to add that lead, 207.2, gives me 325.2 grams. That's how many grams are in 1 mole of PbC2H3O2. Alright, then I'm going to take 1.03, multiply by 1, divide by 325.2, gives me a really small number, 0.003. We got 3 sig figs, so let's keep that trend going and call it 17 moles of lead acetate. Alright, now that we have moles and moles, we're going to divide by our lowest answer. It looks like 0.00317 is our lowest answer. It's nice for this guy, our anhydrous, this gives us 1. Usually our anhydrous is always going to be just 1. If it's not, you probably did something wrong. Usually a calculation mistake. Alright, 0.01. The glare. 0.01 divided by 0.00317 equals 3.15. And when you have something like this with the hydrates, it's a good rule of thumb just to round it to the nearest whole number. Unless it was something like 3.5, then I would multiply all of your numbers by 2 to get a whole number. But on the test, generally just round to the nearest whole number. So that gives me a 3-to-1 ratio. So I'm going to rewrite this guy as BB C2H3O2. There's one of them and 3 of the waters. And that is how I find the empirical formula of a hydrate. Thank you for watching.